In section 1.3, we're starting to talk about one of the most fundamental operations in algebra, which is the addition and subtraction of integers. And in case you've forgotten, an integer is, from the text, an integer is a whole number, either positive or negative or zero. And when we think about adding and subtracting whole numbers, we usually tend to think about them or visualize them in terms of a number line, which I've drawn up here at the top crudely, where 0 is in the center, and positive infinity is all the way to the right, negative infinity is all the way to the left. So for example, if we had a number and we wanted to locate it on this number line, say the number was 3, we'd simply start at 0 right in the middle, and we'd move to the right 3 units, 1, 2, 3, and there's where 3 is. Again, positive goes to the right from 0, negative goes to the left from 0. So again, if we had, say we had negative 3 instead, negative 3, we would start at 0, and we would move to the left 3 units, 1, 2, 3, there it is, negative 3. So we have to start thinking about addition and subtraction as sort of the same operation in that it denotes a movement along this number line. And it's really two sides of the same coin, so to speak. So let's say we had 2 minus 2. Well, you know that's 0. And the idea here is not to reteach arithmetic, but to start thinking about these operations in terms of this number line as a combination of values that exist on this number line, either as positive or negative. So for example, for 2 minus 2, we would think of this as starting at 0, moving to the right 2 units, and then we have a negative, so moving to the left 2 more units. And that brings us back to our resultant, which is 0. And it might not seem overly complicated now, but as I'm sure you read in the textbook, there are going to be scenarios in the future where either by design or by accident, there's going to be some complicated signage on the numbers that you're adding and subtracting. So I wrote down a couple of examples from, basically these are the examples from the table in the back of 1.3, and we'll just run through them real quick so that I can give you an idea of what I'm thinking when I do these operations. Because this is going to come up a lot. I mean, you have to realize that algebra is essentially the use of math models to find solutions to problems where you're given certain amounts of information and asked to find others, such as in the number of fish and fin leg problem that we did in the previous video. You know certain things, you don't know other things, so you need to plug information into an equation that's predetermined or that you derived yourself and then solve for the unknown variable. And you can imagine a situation where, such as in the fin leg example, if I was going to put in my b and my n and my lowercase a, I might have to put in positive or negative values into those variables, just as an example, and I may have to reduce those signs to something simpler using this technique. Anyway, enough about that. Let's get to these examples. So, example 1, we've got positive 3 plus positive 7. And I'm just going to relate each one of these back to this number line just because that's the way I think about it. That's my favorite way to look at it, and I think that I'm not alone in that. So again, positive 3, well, that's, positive 3 is a right-hand movement on the number line. We're combining it, that's one way to think about it, we're combining it with a positive 7. And those are all right-hand movements. So basically what happens here, we have a positive plus a positive, well, that's a positive. Starting at 0, moving to the right 3, 1, 2, 3, moving to the right 7 more for a total of 10. 1, 2, 3, 4, 5, 6, 7, all right-hand movements. So this can be replaced with 3 plus 7, which is equal to 10. And actually, you know what, I'll just leave the equals out there. Pretty simple. That one's real straightforward. I'm sure you got that in your head. But this next one may be a little bit more confusing. Excuse me. There's two things written here. Just to illustrate that it doesn't matter if it's plus a negative 7 or minus a positive 7. This is essentially saying that this is the same operation. And again, if you think about it in terms of that number line, you should be able to sort of lead yourself down that rabbit hole on your own and come to the same conclusion. But positive 3 plus a minus 7, well, that's going to be a 3-unit right-hand movement on the number line combined with a 7-unit left-hand movement on the number line for a result that will be negative 4. And I'm just going to very quickly do that on the number line. I wouldn't do this, I wouldn't actually write this out if I was working a problem, but I do think about this in my head each time. Starting at 0, go to the right 3, 1, 2, 3, and then left 7, 1, 2, 3, 4, 5, 6, 7. Hey, look at that. There's negative 4. And again, if we did the exact same operation with this other organization here, down here, positive 3 minus positive 7, again, we go to the right 3, 1, 2, 3, and then we'd do, we'd subtract 7 units. We do a left-hand movement of 7, 1, 2, 3, 4, 5, 6, 7, and find ourselves once again at negative 4. So they're the same operation. We can replace them with the same thing. We end up with a result that's on the left-hand side of 0, and it's negative. And we know that the difference between these two things is 4. We can replace either this positive and this negative, or that positive and that negative, with simply a negative. And that's the cooked-down version, is that a positive plus a negative is a negative. So we've got 3 minus 7. Finally, the hardest one to visualize with the number line, but perhaps because of that, the easiest one to remember is two negative signs together that are adjacent to each other, and that's going to result in a positive sign. Up here on the number line, you've got a double negative here. Think of it like that. So I'm going to have a right-hand movement, 1, 2, 3 units. And then I'm going to subtract my negative movement. That is to say, I'm going to inverse my left-hand movement. So really, it's going to be a right-hand movement. 4, 5, 6, 7, out to 10. I get that right. 3, 4, 5, 6, 7, 8, 9, 10. Yep, so 10. So again, we have a result of 10. We're going to have a double negative here where we subtract a left-hand movement, which will equal a right-hand movement. So we're going to replace this positive 3 minus a negative 7 with just 3 plus 7. And that's it. If it's a little bit confusing, again, just think about it in terms of this number line. And movements from 0 left or right with respect to the sign, and you should be able to cook these signs down into something a little bit more reduced that you can work with a little bit more easily.